Okay, for the next bit, we're going to be simplifying algebraic fractions. So let's take a look at doing this. All right, so these ones are nice and straightforward. So I'll start off with the first one, which is 24x to the 6 over 12x squared. That's a 24, by the way. I'm sorry, it doesn't look too good. Okay, so the first thing we do is we're going to factor out these coefficients being the things in front of an x. And what the question we're going to ask is either we could say, well, what's common to 12 and 24? And then divide both by those things. Or we could say, how many times does 12 go into 24? And that's what I'm going to ask here, because it goes in exactly. Well, 12 goes into 24 twice, so I can just cross those out and just write a 2. So the first part of the answer is a 2. Then I've got an x to the 6 over x squared. So I can put x squared, so that's going to be x times x, over x times x times x times x times x times x. And I need a longer vinculum there. So how does all that play out? Well, we know that x divided by x, anything divided by itself is 1. X divided by x is 1. And what am I left with? I'm left with 2. 1, 2, 3, 4, x to the power of 4. So that's one way of doing it. Another way would be to say, well, I've got 24 x to the 6 on 12x to the 2. What's common to 12 and 24? Well, 12 is common. And if I divide 12 by 12, I get 1. If I divide 24 by 12, I get 2. Now, when I multiplying variables, so let's say I was going to multiply, let's say, x squared times x to the 3 times x to the 5. If I'm multiplying things where the bases are the same, that's they're all x's, they're not x and y's or something else, then I can just add the powers. So in this case, 2 and 3 is 5, and 5 makes 10, so this would be x to the 10. So when I'm multiplying them, I'm adding the powers. But when I'm dividing them, I'm subtracting the powers. So I could just rewrite this as 2 over 1, if you like. And then it got x to the 6 minus 2. Well, 6 minus 2 is 4. So it's going to equal, I'll write it underneath here, 2x to the power of 4. So two different ways of doing the same thing. All right, let's take a look at one more. I'll do g. G looks rather exciting. I've got 12, here we are, I'll write it out, 12x squared y to the 4 over 3xy to the 3. Well, how does that all play out? Well, what's common to 3 and 12? Well, they're both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So the first part of this is going to be 4 over 1. And anything over 1 is just, we're going to get rid of that one straight away. But I do have an x squared and an x to the 1. It doesn't say 1, but if it's x is on its own, it means x to the 1. Well, 2 minus 1 is just 1. So it's just going to be x to the power of 1, or I can just say x. Now I've got an x to the 4. Well, 4 minus 3 is 1, which will be y to the 1, or just y. So that just equals 4xy, because anything divided by 1 is itself. And there's the answer. All right, let's do just one more. I'm looking at the list here. How about this one here, 5x to the 3 over 2x. 5x to the 3 over 2x. Well, this is a bit of an interesting one because there's nothing common to 2 and 5. So it just stays as 5 over 2. But this is an x to the 1, really, and this is an x to the 3. So I could keep the x on top and say 3 minus 1 is 2. So the answer is 5x squared on 2.